we will start with partial application. We will touch partial application, create functions, forward compose, and we will implement our own list with for each, map, and filter operations. And we'll see how we could compose this operation together to make very complex operations on this list. Let's start from the first video, partial application. In this video, we will talk about partial application of functions and code reusability. What is partial application? It's a process of creating new function with smaller amount of arguments. Sounds interesting? Let's see how it works in Kotlin. Imagine a function that calculates the final price. It takes original price. Also, it would take discount in percent. Let's call this argument pDiscount. Also, to this price, fixed discount would be applied. The final calculation would be original price multiplied by 1 minus pDiscount, and after that, again, we'll apply minus fixed discount. That's all. Imagine now we want to show to user all different discount for the same item in our store. Original price of item would be always the same, but discount could be vary depending on the type of user, maybe some promotion, day of the week, and so on. In this case, calling function price and always passing their original price would be redundant. What if we could create a new function that will already have the original price and only two arguments, pDiscount and fDiscount? Let's create this function. Let's call it price100. The original price in this function will always be 100. Looks good. What we've done here, we actually reused our price function to create a new function, price100, and reduce number arguments. Basically, what we did, we partially applied price function with a first argument of 100. But as you can see, it's a lot of code for such a simple operation. Let's see how we could make it better using Kotlin. First of all, we'll need to create a function that will allow us to do the partial application. We'll use generic programming. So, what we have now? We want to partially apply function price. This function have 3 arguments and 1 result. Let's create a function starting with 4 generic parameters. T1, T2, and T3 would represent the types of arguments, and R would represent a result. And now we will use one more Kotlin feature, is extension function. As you remember, we already discussed extension function previously, and now I will show you how we could extend a function with extension function to match a signature of a price. We will now describe a type of price function that will look like that. We have 3 arguments and the result, which is generic. It means that we could not only use it for the price function, but for other functions that have 3 arguments as well. Now let's create an extension. Let's call it partial1. This extension will accept the single argument with type of t1. Result of this function would be function with two arguments, only t2 and t3, and same result. And now let's write an implementation. First of all, since we're returning a function, we'll need to use syntax for the lambda, the curly braces. Inside the lambda, we'll need to declare two arguments, t2 and t3. We not necessarily need to describe explicitly types, because it would be automatically inferred from the type signature. Now, since we create an extension function for the function with the same signature, we could refer this function inside the lambda using this. Now, what we need to do, it's call invoke on this with arguments of t1, t2, and t3. As you can see, what we've done here, we create an extension that accepts one argument and then pass it inside newly created lambda with two arguments. This will allow us to reduce amount of arguments we use. And now let's try to create a price hungry from a price. The only difference here would be is that since we producing the lambda, we'll need to store it inside a variable, not like function as a named function. Let's call newly created lambda p100. And p100 would be, now we came close to the key point. First, to call the partial application, we need to convert price to lambda using function reference. After we did it, we could call partial application function. And pass there 100, like we did it here for the price 100 function. As you can see, we achieve same result with much less verbose syntax. Looks very simple. The only problem is that we will have to implement this function every time where we need it. Fortunately for us, library called arrow and functionale already solved this problem and provides all kind of function that could apply partially any function with any amount of arguments. Now, finally, let's call p100. Let's see what price would be if we'll get 20% discount and $10 discount voucher, for example. From 100, price reduced to 70. And the small bonus is calling function on lambda will be no different in a code than calling just named function.